from Oxnard College will be presenting her research on behalf of her study team.
All right. Woo!
Good morning, everybody. I'm Lindsay. I am a dental hygiene student at Oxnard College. And today I'm here representing my team and our project, the detection of gender differences in the oral microbiome. So what is the oral microbiome? It kind of depends who you ask. I like the human oral microbiome database. They list 700 prokaryote species, and they're funded by NIH, so you can kind of trust them. And then it's comprising the oral cavity, so basically anything inside of your mouth, hard and soft tissue. And recent research reveals that the mother's oral microbiome can be transferred to the fetus in utero. So of these 700 species, these bacteria can cause disease and cause some serious diseases. For one, periodontitis is chronic inflammation, it's irreversible, and it affects about 50% of the population. Slightly higher in women than men, but not significantly. The oral bacteria is also implicated in cardiovascular disease, which is the #1 killer of men and women in the US. And then it plays a huge role in diabetes. It's like a back and forth relationship there. And also a number of lung diseases. It's also indicated in like stroke and Alzheimer's disease. So another significance of the oral microbiome is its relationship to adverse pregnancy outcomes such as preeclampsia, preterm labor, low birth weight, neonatal sepsis, and chorioamnionitis. So we decided we were going to set out and see what we can see what's in our mouths, how much is in there, and then to further explore any differences that there may be between the two genders. And the samples we took were from healthy people. We didn't really suspect there to be any significant differences between the two. So what we did, we took this nifty little brush here and we swabbed our mouths. We had 6 people, 4 females, 2 males. So we take it, isolate, prepare the DNA, and we send it off for Illumina next generation sequencing. And here's the MySeq machine here that does the next generation sequencing, and then it provides digital analysis with different counts and stuff. So they use a bridge amplification, which this is like part of the diagram, kind of shows you how the strands are copied. And then they use sequencing by synthesis, which is like a proprietary technology where the nucleotide bases are detected as they're being added. And then so our results, we got 164 species back, which were determined for 20 million sequences. So each count that we got represents about 200 identical counts. The total bacteria, on average, is about 100,000 on average between the 6 samples, from 85 to 120,000. And then all female counts were higher than all the male counts. So this is how our data was brought back in kind of like an Excel-style sheet here. So we have all the species listed on the left, and then our 6 samples. So like the 2 male and 4 female, and then we went through and averaged them. And then for our analysis, we worked based on the averages. So these are the 12 that really stood out once we got the averages and started looking at the numbers. And so we have 12 different species, and we broke them down into 5 different categories. These are the categories that I'm going to go through here. So our first one is abundant differences greater than 5-fold for bacterial species. Abundance we characterize as 10,000 or more counts. And then And these are the 7 species we got. 5 of them are involved in periodontitis. All of them are related to some sort of disease. And the one that I thought was most interesting is the capnocytophagia at the bottom. It was the only one higher in males than females. All the others were higher in females. And periodontitis, but specifically the adverse pregnancy outcomes. I thought that was kind of interesting. And then our second category is bacteria whose abundance is greater than 5% of the total population detected. And again, we have 7 species, all of them involved in disease, and 5 of the 7 involved in periodontitis. And again, the only one higher in males was the Fusobacterium nucleatum, which is involved quite often with preterm labor and colorectal cancer. And then we have the one species that differs between men and women by 20 times. So it's the Haemophilus parainfluenza. It's involved in periodontitis, endocarditis, neonatal sepsis, all kinds of things. But it's also pretty normal flora in men and women. But in our female counts was significantly higher, obviously 20 times higher. And then our next one is the bacteria present in one gender and absent in the other. This is the Neisseria perfluva. It was present in all female samples, absent in all male samples. And it's just like normal oral flora and also respiratory flora. And then our last category here, high abundance in both genders. So this is the Streptococcus sanguinis. It's in your mouth all the time. It's probably in everybody here. Very normal bacteria of your mouth. So this one got our highest counts for the male and female counts. It has been indicated in endocarditis, but for the most part it's not really an invasive bacteria. And then because the counts are so high in both, we thought that we could use this as a control for future experiments. And so where are we going with all this information? We can study some future communities and biofilms of bacteria that contribute to pathogenicity. On the same note, study in healthy individuals. As far as like future tests, run bigger samples, the 18S RNA used for studying the eukaryotes in there, and virome, like how the viruses are affecting what's going in our mouths and other systems related to that. And we also need more information as far as how the microbiome is transferred to the fetus and to babies in birth. Some of the advantages of microbiome testing are we could take samples from like your regular dental visits, twice a year, right? Twice a year. And it can aid in predictive disease evaluation, assessment of overall health, rapid detection of disease, incest inflammation, and then of course help to improve pregnancy outcomes and help in that regard is kind of an important one for me.
No.
But I kind of jumped the gun on that one. Now I'm going the wrong way. I'm sorry. But I wanted to end by saying that, or just kind of reiterating that our samples were taken from 6 healthy people, and the 12 species that stood out are, if you look at the CDC, there's the top 10 causes of death for people in the US every year. And our 12 species from healthy people related to 7 of the top 10 causes of death. And that's just in health. So in exploring the microbiome and exploring these relationships, determine how we get from healthy to disease with these bacteria. That pretty much sums it up there. And here's a lovely picture of my crew here. And yeah, that's it. So any questions? Yes.
And I am not the designated question asker in here, honestly. What do you think the you chose to look at gender differences, so are other than preterm labor and things like that that can affect pregnancy, what implications are there for the genders? And another question is, did you purposely choose a small sample size? And within that sample, does everyone use Crest and go to the dentist like twice a year and all that kind of stuff? Were those kind of things controlled for? This was wonderful research. I've never seen anything like this. So the questions are not criticisms. I'm just more curious.
Oh yeah. There's a lot of curiosity around this. Like it involves everybody. So no, we did not take anybody's oral care really into account. We took people who were in the lab as kind of convenience and cost, and who were really sure, what was going to come of it. So we kind of went with accessibility. And
is that why you also went with gender differences as well, because of your convenient sampling, or were you really wondering if there was a difference between the genders?
Well, I was curious. There are a number of ways you could analyze the data, and you kind of have to choose one. I think we just thought that would be more interesting.
Awesome.
Thank you. Yes?
I was wondering that during your information of setting up your study design, if anywhere in the primary literature you found any type of study that would indicate that the oral biome changes as we age. And the reason I'm asking this is because it was really interesting that the bacterial species that were coming up were correlated with disease, and specifically the one that was different between the male and the female species. The male and the females was one related to colorectal cancer, and that is higher in men than it is in women. So I'm just curious as to if you found anything with regard to that.
There is a lot of data on age. We didn't really go into that. We were focused more on gender, but age is definitely a factor, and also just with periodontitis in general, as you age, almost everybody has a version of it, and that correlation with the other diseases, like, it would make sense that as you age, that would be more of a factor. But no, we didn't really explore that.
There's so many uses for this data here, just like she's saying, with age, with immunocompromised patients, with pregnant patients. I was thinking you could find a group that are taking antibiotics and look at antibiotic use and how that changes the flora.
Right.
Is there any indication that with personalized medicine that they are going to be doing some kind of testing for this, some kind of...
For the bacteria?
Yeah, like a personalized sequence of the oral microbiome, like especially with pregnant women.
Right. There is, and some dental practices use that specifically for dental disease. It's not really for anything else. So it's there.
Okay, that's
it's
good.
The beginnings of it.
Cool.
There.
I
Yeah.
have a quick, sorry, did you have a question?
Was there another question here?
No.
Okay.
I have
Oh, yes.
Are we looking to compare the human microbiome, the oral microbiome, between healthy patients and see the ratio differences between the healthy and unhealthy patients?
Yeah, I think that would be great. Like someone who has, a diagnosed disease and explore what's going on.
Yeah, because it has been shown like the ratio differences between a specific bacteria and another. Just the numbers might have an influence on the development of the disease. Because you do have the pathogens, like potential pathogens, but if they're not the correct amount of numbers,
Right.
The disease is not gonna be, like, launched.
Right. Yeah, it's the numbers of it, and it's not really just the one species, so it's kind of like multiple numbers and how they interact, and I mean, there are other factors at play, but it's kind of like the community of it, which is why like testing the microbiome as a whole is kind of important and determining how those interact with each other in disease.
Actually,
One more question? One more question?
Just
Quick
a
question.
question.
Yes.
So for the next generation sequencing, right, you had 6 samples.
Uh-huh.
How much was it per sample?
It was like 80 per sample.
$80 per sample?
Yeah.
This could be useful in ventilator-assisted pneumonia. That's my last comment.
Oh.
Or microbiome, the pneumonia people get on intubation.
Yeah, definitely.
I'm excited for you.
How to do oral care.
Thank you.